Number 10 here shows an example of what is called a probability distribution. A probability distribution shows all of the outcomes of an experiment, and this experiment is not really defined, just we know that the outcomes of this experiment are only going to be the numbers 5, 6, 7, 8, or 9. And underneath each outcome, its respective probability. So the probability of 5 coming up has 14%, probability of 7 is 21%, probability of 8 is 30%, and probability of 9 is 11%. Now there is one probability missing. Since these are all the outcomes that are possible, that means the probability that one of these outcomes happening is 100%. There is no other outcome in this experiment. If there was, it would have to be listed. So we can calculate the probability of 6 happening by taking 1 and subtracting out each of the probabilities for 5, 7, 8, and 9. 1 minus 0.76 is equal to 0.24, which means that in here should be a probability of 0.24. Now, what is the probability that a number at least 7 pops up, right? The word at least 7 indicates 7 or more, right? Anything that's 7 or higher. So that would be, since this is an OR statement, the probability of 7 plus the probability of 8 plus the probability of 9. So these three values over here added up gets you 0.62. In order to calculate the mean, what you're going to do is take each respective probability and multiply it by its outcome. So 5 times 0.14 plus 6 times 0.24 plus 7 times 0.21 plus 8 times 0.3 plus 9 times 0.11. And that's going to get you 7. In order to calculate the standard deviation, you're going to take the outcome to the second power multiplied by its respective probability. That's 5 to the second times 0.14 plus 6 to the second times 0.24 plus 7 squared times 0.21 plus 8 squared times 0.3 plus 9 squared times 0.11. And this gets you some value, which you will subtract 7 to the second power, and that will get you this answer here, 1.24, the standard deviation for this probability distribution. In order to use a calculator, we can input these values into L1 and L2 and calculate one variable statistics. So let's take a look. In here, in stat and edit, in L1, I put in 5, 6, 7, 8, 9, the outcomes. Now take a note, for this emulator, it did not let me put in 0.14, 0.24, 0.21, 0.3, and 0.11. In your TI-84 calculator, it will. So that's what I want you to put in. I had to fudge it for this calculator in order to make it work. Let's hit stat. We'll hit calc. Now I know there's two lists, but we're still doing one variable statistics, and here's how we're going to work it. L1 is our data. L2 is going to be our frequency list. So I guess this calculate 84 is looking for whole numbers, but if you put in the decimal values into a TI-83 or TI-84 standalone calculator, it should work. So let's put in L1 for a list, L2 for our frequency list, and hit enter. Now it shows us our mean is 7, which is accurate. It shows us the sum of our x's is 700, which is not accurate. The sum of our x squareds is 5054, which is not accurate. Thankfully, we do not really need those numbers anyway. But we're taking our sigma x, which is 1.24, and that is our inaccurate number. Right, so putting in all of those percentages as whole numbers changed a little bit, but actually didn't change the numbers that we want, which is a good thing. So 7 is the mean, and 1.24 is